Hello everyone. We are Group 3. Our members are Alex McCord, Nicholas Gerber, Chris Ritter, and myself. My name is Kim Scarbello. And our final project for this term was a fitness studio management software system. And I'm going to tell you all about that. So, for our project, the potential client would be a new fitness studio business owner who owns a space but doesn't quite have the system to get new customers, to collect payments, to onboard new instructors, to manage the schedule, to pay instructors, and basically keep the business running financially, scheduling, um, staffing, and all of that. And so the problem solved is someone without this software would have to keep records of member payments. They would have to collect them in person, would have to check everybody's membership record before every class to make sure they're a member. It would be harder to onboard and add new instructors to their setup, and issue payments back to those instructors when they have completed the classes. So it basically puts all of the basic fundamental needs of a fitness studio together in one spot. So the criteria for this to be successful would be a scheduling system where customers and instructors can enroll in different courses based on their schedule. It would accept membership payments, membership enrollments. It would make available teaching assignments for local instructors. It would offer payment for instructors, and all of that. And so some of the constraints would be for the system that all the customers must have a membership in order to go to the classes. Instructors must be able to accept the open class assignments freely. Studio rooms in the studio shouldn't be double booked. Instructors should receive payment for the classes taught. And yeah, so I'm going to show you our first diagram that we created, which was the use case diagram. So here's ours. We have identified the primary actors here on the left side and the secondary actors on the right side that are a part of the system. And in the middle we put in our different use cases, and the use cases we focused on were purchasing memberships, canceling memberships, enrolling in a class from the schedule, and unenrolling from a class. There's our instructors who need the option to accept an available teaching assignment from the schedule, and they also need to complete attendance forms and completion just to verify that the classes were completed and to log attendance. And then the other main actor, primary actor, would be a studio staff member that is responsible for creating new teaching assignments that instructors can take. So they would publish those into the system for instructor consumption, and also verifying that classes have been completed, and issuing payments out to instructors when they have been completed.
Hi, I'm Chris, and now I'll present our system context class model, which defines the boundary between our fitness studio management system and its external environment. So this diagram shows our system as a black box. We're not really looking at internal components yet, just how the system interfaces with the outside world. The center shows our fitness studio management system as a single aggregate class with the software system stereotype. Around it, you can see all the external entities that interact with our system. Let's walk through the external actors right now. So you can see there on the left, we have our human actors. Our main three are the customers, instructors, and studio staff. And we also put a developer on the right side. These are all marked with external user stereotypes and shown as stick figures. On the bottom, we have the external systems, our database, and this stores all persistent data for classes, memberships, and transactions. Then we also have the external devices. So we have the physical billing form, the physical payroll form, physical attendance chart, authentication scanner, class sign-up calendar, membership management manager device, and the account creation device. Now, each external device has inputs or outputs from our system, and you'll notice that the multiplicity indicators, for example, many customers can interact with one system, more than one system. And the significance of the system context class model is crucial because it clearly defines what's inside versus outside our system scope and identifies all interfaces we need to implement. It shows the data flow points that need security and validation, and it helps us understand the complete ecosystem that our system operates in. This context model forms the foundation for our more detailed static and dynamic models that my teammates will present on next.
Hello, my name is Nick, and I will be presenting our static model diagram. This is basically a visual representation of the main entities and the relationships within our system at a specific point in time. It shows an organized view of how the components interact. So looking at this static model here, we can see that the class entity is related to most of the others. So that's how I'll start. So first of all, a class session is described by a class offering, and it is taught by a single teacher who then completes the class reports for the sessions that they teach, and those class reports then populate into the class attendance records, which holds as many reports as it needs to. This report also triggers an instructor payment to the specific instructor who wrote the report. And moving into that, you can see that the studio staff member is the one that verifies and authorizes the instructor payment. And that is a one staff member for each payment. And the staff members also create entries for the class session. So basically, they create the schedule that the teachers and students can sign up for. And they also verify the membership payment of the customers. And the customers are able to enroll in each class session, and the class sessions are attended by as many customers as possible. And so the customer is able to browse the schedule, which holds all the class sessions that are an entry in it. And they are also able to authorize a membership payment, which then procures the membership. And we can see our entity classes here, where they have all the numbers and digits with integers, strings, and mostly date times.
Hello, my name is Alex, and I am discussing our dynamic model. This is our communication diagram that shows the dynamic interactions among the main objects and controllers in our Fitness Studio system. It focuses on how components collaborate to fulfill user requests rather than just their static structure. At the center, the UI, which would be our Studio app, serves as the main interaction point for the three actors that we have, which are customer, instructor, and studio staff. And whenever a user performs an action, such as booking a class or managing a membership, the UI sends a message to the appropriate controller. For example, the scheduling controller handles class scheduling and validates requests, while the membership controller manages membership, purchases, renewals, and cancellations. Each controller communicates with supporting services and repositories like the class session repository, payment service, and report controller to process data and return results back to the UI. For instance, the scheduling controller uses the class validation service and the class session service to confirm classes availability before creating or modifying a booking. This model fits in the overall Fitness Studio application by showing the runtime flow of information between system components during real use cases, and it helps clarify responsibilities, ensures the consistency of messages that are being passed around, and demonstrates how the system maintains modularity and cohesion across controllers, service, and repositories.